Hello students, good morning. Welcome back to a new video of Sunanda's tutorial. So today we will discuss about the Earth's layer, or basically about the lithosphere, about crust, mantle and core. In my previous videos, that means in part 1, part 2 and part 3 video of ecology, I have already discussed about the basic concept of ecology, then atmosphere, then hydrosphere. So today we will discuss about the lithosphere. So the interior of the earth is made up of several concentric layers, of which the crust, mantle, outer core and inner core are significant because of their physical and chemical unique properties. So the earth layers, interior of earth is made up of like this. That means concentric layers. The outer one, crust, then mantle, then in outer core and then inner core. The crust is a silicate solid. That means silica is present. Mantle is viscous molten rock. Outer core is a viscous liquid and inner core is dense solid. So these are the characteristic features of basic characteristic feature of different layers of earth. Mechanically, the earth layers can be divided into lithosphere, then asthenosphere, then mesospheric mantle, means the part of the earth's mantle below lithosphere and the asthenosphere, then outer core and inner to it, the inner core. Chemically, earth can be divided into crust, which is the upper layer, then upper mantle, which is inner to crust, then lower mantle, then outer core and finally inner core. So these are various layers of the earth. Then this is a structure where the outer layer is crust, then the asthenosphere, then mantle, then outer core and inner core. And this is the lithosphere. Lithosphere, which consists of the outer crust and uppermost solid mantle. So these are the lithosphere. These two layers, crust and uppermost solid mantle. Then the mantle layer or inner mantle layer, then outer core and inner core. This is the layers of the earth. Then the first outermost layer, which is the crust. Crust is the outermost layer of the earth, and it is less than 1% of earth's mass. Density increases with depth and average density is about 2.7 grams per centimeter cube. The thickness of the crust varies in range of 5 to 30 km in case of oceanic crust and 50 to 70 km in case of continental crust. That means when there is ocean, the crust or the depth of the crust or thickness of the crust is 5 to 30 kilometers. But when it is continental part or continental surface, the crust is about 50 to 70 kilometers. Then the continental crust can be thicker than 70 kilometers also in the areas of major mountain systems. And it is as much as 70 to 100 kilometers thick in Himalayan region. The temperature of the crust increases with depth, reaching values typically in the range of about 200 degrees Celsius to 400 degrees Celsius at the boundary with the underlying mantle. The temperature increases by as much as 30 degrees Celsius for every kilometers in upper part of the crust. As it goes down, the temperature increases. The outer covering of the crust is sedimentary material, and below that lies the crystalline, igneous, metamorphic rocks which are acidic in nature. Then the lower layer of the crust consists of basaltic and ultra-basic rocks. The continents are composed of lighter silicates, that is silica and ammonium, also called Cl, while the ocean have heavier silicate, that means silica and magnesium, which is called Sima. So in continents, the outer layer consists of silica and aluminum, while in ocean they have heavier silicate which consists of silica and magnesium. In case of continents they are known as seal, and in case of marine or oceans they are called as sima. The continental crust is composed of lighter, that is felsic, sodium, potassium, aluminum silicate rocks like granite. The oceanic crust on the other hand is composed of dense, that is mafic, iron, magnesium silicate, igneous rocks like basalt. Then the lithosphere, it is the rigid outer part of the earth with thickness varying between 10 to 200 kilometers. It includes the crust, that means the outer layer, and upper part of the mantle. The lithosphere is broken into tectonic plates. It consists of many tectonic plates like this. And the movement of these tectonic plates cause large scale changes in the earth's geological structure like folding, faulting. The source of heat that drives plate tectonics is the primordial heat left over from planets formation as well as radioactive decay of uranium, thorium and potassium in Earth's crust and mantle. Then the mantle layer. The mantle is about 83% of Earth's volume and holds 67% of Earth's mass. It extends from Moho's discontinuity to a depth of 2,900 kilometers. The density of upper mantle varies from 2.9 gram per centimeter cube to 3.3 grams per centimeter cube. The lower mantle extends beyond asthenosphere. It is in a solid state, and the density also varies from 3.3 gram per centimeter cube to 5.7 grams per centimeter cube in lower mantle. The mantle is composed of silicate rock that is rich in iron and magnesium relative to overlying crust. Regarding its constituent elements, the mantle is made up of 45% of oxygen, 21% silicon and 23% magnesium. So overall OSM, the mantle contains OSM, that is oxygen, silicon and magnesium. The mantle temperature of the mantle is approximately 2000 degrees Celsius at the upper boundary, with the crust to approximately 4000 degrees Celsius at the core mantle boundary. That means at first the crust layer is present and then the mantle. So here the temperature is about 2000 degrees Celsius, but inner to mantle core is present. So here the temperature is about 4000 degrees Celsius. So it varies and it increases with the depth. Because of the temperature difference, there is a convective material circulation in the mantle. Although solid, the high temperature within mantle causes silicate material to be sufficiently ductile. Convection of the mantle is expressed at the surface through the motion of tectonic plates. High pressure conditions ought to inhibit seismicity in the mantle. However, in subduction zones, earthquakes are observed down to 670 kilometers. Then asthenosphere, the upper portion of mantle is called asthenosphere. Astheno means weak. Just below the lithosphere, it extends up to 80 to 200 kilometers. It is highly viscous and mechanically weak and ductile, and its density is higher than the crust. Then the properties of asthenosphere aid in the plate tectonic movement and isostatic adjustment. The elevated part at one part of crust area is counterbalanced by the depressed part of the another. It is main source of magma. It is very important point. The asthenosphere is the main source of magma that finds its way to the surface during volcanic eruption. So it is very important point. Then the outer core. Core is the innermost layer, and it is divided into two parts. One is outer core, one is inner core. Outer core surrounding inner core lies between 2900 kilometers and 5100 kilometers below the Earth's surface. The outer core is composed of iron mixed with nickel, that means knife, and trace amount of lighter elements. The outer core is not under enough pressure to be solid, so it is liquid, even though it has composition similar to inner core, but it is liquid. The density varies between 9.9 gram per centimeter cube to 12.2 gram per centimeter cube. The temperature of outer core ranges from 4400 degrees Celsius in the outer region to 6000 near the inner core. Dynamo theory suggests that convection in the outer core combined with Coriolis effect gives rise to Earth's magnetic field. So it is very important point. According to dynamo theory, the convection of outer layer of the core combined with Coriolis effect gives the Earth's magnetic field. Then the inner core. The inner core extends from the center of the Earth to 5100 kilometers below the Earth's surface. The inner core is believed to be composed of primarily of iron and some nickel, that means knife. Since this layer can transmit shear waves, it is solid. The Earth's inner core rotates slightly faster relative to rotation of the surface. The solid inner core is too hot to hold a permanent magnetic field. The density varies between 12.6 gram per centimeter cube to 13 gram per centimeter cube. The core accounts for just about 16% of Earth's volume but 33% of Earth's total mass. Scientists have determined the temperature near Earth's center to be 6000 degrees Celsius, 1000 degrees Celsius hotter than the previously thought. So previously it was thought that the Earth's center temperature is 5000 degrees Celsius, but now scientists have discovered that the temperature near the Earth's center is 6000 degrees Celsius. 6000 degrees Celsius, this iron core is as hot as the sun's surface, but the crossing pressure caused by gravity prevent it from becoming the liquid. So it is all about the details of the layers of Earth, or the layers which are present below the Earth's surface, and about lithosphere, asthenosphere. So these are all about this. In my next videos I will explain other topics related to biology. So stay tuned, and please like, share and subscribe my channel. Thank you.